16097.
Assalamualaikum, my name is Muhammad Nafiuddin Misai Kubahari. My matric ID is MA1617.8.
Hello, my name is Abdul Rahman bin Muhammad Azmi. For the PBL2, we choose the question number 4.
Okay.
This is our question number 4. The question is consider a regenerative vapor power cycle with two feed water heaters, a closed one and an open one, and reheat. Steam enters the first turbine stage at 12 megapascal at 480 derajat Celsius and expand to 2 megapascal. Some steam is extracted at 2 megapascal and fed to the closed feed water heater. The remainder is reheated at 2 megapascal to 440 derajat Celsius and then expands through the second stage turbine to 0.3 megapascal, where an additional amount is extracted and fed into the open feed water heater operating at 0.3 megapascal. The steam expanding through the third stage turbine exists at the condenser pressure of 6 kilopascal. Feed water leave the closed heater at 210 derajat Celsius at 12 megapascal and condensate exciting as saturated liquid at 2 megapascal is transferred into the open feed water heater. Saturated liquid of 0.3 megapascal leave the open feed water heater. Assume all pumps and turbine stage operate isotropically. Okay, we have 4 questions, A, B, and C. Okay, this is our schematic diagram for our question number 4. We have pump 1 and pump 2, and we have open and closed feed water heater. Okay, this is for our TS diagram. Okay, for line 1 we have 6 kilopascal, 0.3 megapascal, 2 megapascal, and 12 megapascal. This all from information we get from our question. Okay, first we find H1 to HF for 6 kilopascal, and we get from the TS diagram. This value we get from table A5, but for the get this value we have to interpolation because at the table we have just 5 kilopascal and 7.5 kilopascal. Okay. Next, from this table we can get V1 also. It's 0.00106 meters square over kg per kg. Okay. Next, we find work pump 1 in. We use a formula V1 bracket P2 minus P1, and we substitute a value 0.001009 bracket 300 minus 6 kilopascal, and we get 0.3 kg per kg. Next, we have to find H2. For H2 we use another formula. It is H1 plus work pump 1 in. The value is 150.15 plus 0.3, and we get 150.45 kg over per kg. Okay, next for P3 0.3 megapascal saturated liquid at this one. Okay, we have H3 we got from table is 561.43 kg per kg, and V3 equal to 0.001073 meter cube per kg. And next we find work pan 2 in. We use formula V3 bracket P4 minus P3 is value 0.01073 bracket 12,000 kilopascal minus 300, and we got 12.55 kg over kg. For the next one, we find H4. The formula is H4 equal to H3 plus work pan 2 in, and the value is 561.43 plus 12.55, and we get 573.98 kg per kg. For the number P6 at 2 megapascal at saturated liquid at this point, we get this point H6 is equal to H7 and equal to 908.47 kg per kg, and we get T6 equal to 212.38 largest Celsius. And for next one is we know the T6 equal to T5. T6 equal to T5. And the next one for we go for P8, we have 12 megapascal at this point. We get 12 megapascal, and for T we get 480 derajat Celsius. We get this information from our question, and we can find the value the table value H and S from the table. And next one is for P9 is 2 megapascal, and we can get from table, and we get the H value. H9 value is 2837.38 kg per kg. For this line point 9, S9 equal to S8 because S8 equal to S9 the same line with S position. Okay, next one is P10 0.3 megapascal, and from the table we can get nilai H10 is 272. Okay, for P10 the value is 0.3 megapascal, and from the table we can get nilai the value of H10. It is 2724.9 kg per kg, and S10 equal to S8 because S10 equals to S8. Okay, and
okay, next we have to find H11. Okay, from the information we get from the equation, P11 is 6 kilopascal, and the S value of S11 is equal to S8 that we get from P10. Okay, when we get the value of S11, we have to find X. Okay, to find X we get from the formula S equal to SF plus X SFG. Okay, we have to find this X. Okay, so we substitute X. Okay, we got the value of S11, SF and SFG from the table. So we calculate, we get the value of X11. When we get the value of X11, we can find the value of H11. Okay, just substitute the value that we get. Okay, so we get H11. The value is 2792.86 kilojoule per kilogram. Okay, next we have to find the value of Y. The value of Y we have to H5 minus H4 divided by H9 minus H6. So the value that we get before, we substitute in, and we got Y, the value of Y, and then we have to find value of Z. The bracket H3 minus H2 bracket close bracket minus Y open bracket H7 minus H2 close bracket divided by H10 minus H2. Okay, so the value that we get before, we substitute in this formula, then we got the value of Z. Okay. Okay. From the value we got from we find before, we can find Q in. Q in is H8 minus H5. So the value that we got before, we substitute in, and we can get Q in is equal to 2386.78 kilojoule per kilogram. Okay, next we also can find Q out. That is open bracket 1 minus Y Z minus Z close bracket and open bracket again, H11 minus H1 close bracket, and we substitute that the value we get before, then we can get the value of Q out, which is equal to 1900.31 kilojoule per kilogram. Okay, next, after we find the Q in and Q out, we can find the work net. Okay, work net is Q in minus Q out. So we substitute the value, then we can get work net, which is equal to 486.47 kilojoule per kilogram. Okay. Okay, next, and then after we get all the value, we can find the efficiency, thermal efficiency. So to find the thermal efficiency, we have to, the formula is 1 minus Q out per Q in. So we just substitute the value of Q out and Q in, and then we can get the thermal efficiency, which is equal to 0.2028, and when it convert to percentage, 20.28%. Okay, next, we can have to find the thermal the ideal efficiency, which is the formula is 1 minus TL over T1. Okay, TL is 210 over 480, and then we can get the ideal efficiency, which is equal to 0.5625, when convert to percentage, 56.25%. Then we have to compare the efficiency. The efficiency of ideal cycle is higher than the efficiency of thermal of the above cycle. Okay, that's all from us. Thank you.